Finally, it's time to learn all about logarithms. First of all, you're going to figure out what is a logarithm and how do we evaluate them. So a logarithm is just a special way to ask a very specific question. It's saying what exponent of a given base gives you an answer. Here's how a logarithm is written. Log base b of a is equal to x. I'll read that one more time. Log base b of a is equal to x. Now there's some technicalities on this definition. This only makes sense if b is greater than 0, and technically b cannot equal 1, and x has to be greater than 0. And these conditions will become clearer as we go through the problems. So you're very familiar with exponential form, where I have some base raised to an exponent equals some value. Well, that's equivalent to, in logarithmic form, that log base b of a is equal to x. So these two statements are equivalent. This is what we call an if and only if statement. So b is my base, x is my exponent, and a is the answer, sometimes called the argument. So notice that a logarithm is producing an exponent. Log base b of a is equal to x. To change a logarithm to its exponential form, it's easy to do if you make a counterclockwise loop. So I start at the base, and I go up and around, which gives me b raised to the x power is equal to a. So for an example, log base 3 of 81, let's figure out what that's equal to. Well, first of all, I always put an x if there's no value there. And I make this counterclockwise loop, thinking 3 to the x is equal to 81. So now I'm thinking 3 to what power? Well, I know that 3 times itself 4 times is 81, therefore x has to equal 4. So log base 3 of 81 produces the exponent 4. So what do we do if our log has no base? You will see expressions like log 100. Well, if there is no base written, the base is 10. So this log of 100 is really saying log base 10 of 100. So to demonstrate here, log of 100 is equal to 2 because 10 to the second power is 100. If I have log of 1,000, that's going to be equal to 3 because 10 to the third is 1,000. If I have a fraction like log of 1/10, this is going to be -1 because 10 to the negative first power is 1/10. So we're just going to do some practice now, writing each given equation here in exponential form. So just to hear it read again, this is log base 11 of 121 is equal to 2. So to change it to the other form, again, do a counterclockwise loop. 11 to the second power is 121. The second one, log base 9 of 81 is 2, so that's 9 to the second is 81. Log base 7 of 49 is 2, so that's saying is equivalent to 7 squared is equal to 49. And you will see fractions from time to time. 216 to the 1/3 power is 6. Hopefully you remember that the 1/3 power is the same as the cube root of 216. Now let's go the other direction. If it's given to you in exponential form, well, the base is the same in logarithm form. So this is log base 81 of 9 is equal to 1/2. In 6, log base 16 of 256 is equal to 2. 7, log base 7 of 49 is equal to 2. And in number 8, log base 12 of 144 is equal to 2. It's your turn to practice. There are 8 questions on the screen. Hit pause, hit play when you want to check your answers. Here are the answers to these 8 questions. Now we're going to practice evaluating logarithms using some mental math. So log base 4 of 16 is equal to what? Well, when I don't have what it's equal to, I put a variable there in its place, and I think about, well, what is it in exponential form? So saying 4 to some power is equal to 16. What is that power? It would be 2, because 4 times 4 is 16. All right, so the answer to this is 2. Log base 3 of 27. So I start by changing this to exponential form. Well, I set it equal to x first, and then change it to exponential form. So 3 to the x is equal to 27. So in my head, I think 3 times 3 is 9, times another 3 is 27. So x is 3. So log base 3 of 27 is equal to 3. Now, when it's a fraction, it's a little more complicated. So this is saying 7 to some power is equal to 1 over 343. And I'm going to give you a hint. When there's a fraction involved, typically you're going to have a negative exponent, because negative exponents turn things into fractions. It's the reciprocal. So 343, well, what is that? That's equal to 7 to the 3rd power. So what I have here is 7 to the x is equal to 1 over 7 cubed. So I think, well, if I want to bring 7 to the 3rd back up to the top, the exponent becomes negative. So what's my conclusion here? Well, that the missing exponent is equal to negative 3. So I can say that log base 7 of 1/340 thirds is equal to negative 3. And finally, log base 2 of 1/8. What's that equal to? So again, I have an unknown. I'm going to set this equal to x and find my unknown. So 2 to the x is equal to 1/8. So I'm going to think about, how could I rewrite 8? Well, that would be 2 times 2 times 2, so 2 to the 3rd, which is equal to 2 to the negative 3rd. So what's my conclusion? 2 to the x, or x rather, would have to equal negative 3. So log base 2 of 1/8 is equal to negative 3. There are 4 on the screen for you to practice. Hit play when you're ready to check your answers. So the one that I'm going to walk you through here is number 8. You may have run into some difficulty on this one. So this is saying that 64 to some power, which I'll call x, is equal to 1/4. So first of all, I'm going to go, okay, so I'm going to move this 1/4 up to the top by making it 4 to the negative 1st. That's the same as 1/4. So 64 to the x is equal to 4 to the negative 1st. So how can I rewrite 64 so that it has a base of 4? Well, I know that 64 is 4 to the 3rd power, right? So I'm going to replace 64 with 4 to the 3rd, and I still have this x, so it's really 4 to the 3 times x is equal to 4 to the negative 1st. So what's my conclusion? Well, I know then that 3x, this exponent has to equal the negative exponent. So how do I get x by itself? Divide both sides by 3, so x is negative 1/3. And if you think about that, 64 to the 1/3 is the cube root of 64, which is 4, and if you need it to be a fraction, make it negative, and now it's negative 1/4. So logarithms, though they seem scary at first, are really not bad. They're just exponents. You've got to practice evaluating them mentally, do some practice, and the rest of this unit will go much smoother.